Okay, so this video is going to pick up where we sort of left off in the last one, doing this method of undetermined coefficients. So I'll just give you the quick recap here. So of course we're trying to solve these non-homogeneous ODEs, which of course is one where I have something on the right-hand side, right? So I've got our usual friend on the left that we're very good at solving the homogeneous problem for. So if we had a 0 over there on the right, I'd be in good shape. But we want to get some ideas and techniques for solving this version, right, the non-homogeneous version. And so here's one of our two strategies that we're going to use to come up with a solution. It's called the method of undetermined coefficients, which is not a very creative title, but it is pretty descriptive, because what does this strategy involve us doing? Is first and foremost, of course, we know that if I solve the homogeneous problem first, which we know how to do that already, that's going to be part of my answer to the question. So I'll get my little y1 and little y2. But then this strategy, method of undetermined coefficients, says, well, how are we going to get a non-homogeneous solution? Well, let's do our favorite thing, which is to make a guess. So we'll make a guess that has some undetermined coefficients in it, some letters, right, or some constants that we're going to solve for. We're going to make a guess. What does it mean, of course, to make a guess for a solution? It means, of course, we're going to run the guess through the ODE by plugging it in for y and y prime and y double prime. And of course what's going to happen is we're going to see that the guess that we plug in, there's going to be one or more undetermined coefficients in our guess. And of course we did some examples of this in the last video, and what we saw happening was that these undetermined coefficients become determined, because when we plug the guess in, we get something like this. Let's skip ahead to an actual example. We get something like this, which is a system of equations. So something sort of like these guys over here. So we'll get something where we can say, oh, well, I can actually tell you we made a guess, but what I can do is do a little bit of algebra, and I eventually figure out what in this case, I determine the coefficient that I needed to be part of my original guess. And so then we will have found one non-homogeneous solution. And then, of course, the grand solution, or the overall, putting all the pieces together here, we say, all right, so the general solution, the non-homogeneous problem, is the homogeneous portion. And then you throw in the one non-homogeneous solution that you found. So strategically, that's all well and good, and hopefully kind of makes sense. So I think in the last video we did 3 examples, because of course, if I flash back to our cheat sheet here, or our chart of guesses, the basic idea, of course, is that the guess that I make for a solution is essentially just a generalized version of whatever I see on the right-hand side. So if you have E, I'm going to guess a generalized version of E. If you have trig, sine and or cosine, I'm going to guess a generalized version of sine and cosine. And if I have a polynomial of degree n, however many pieces of it I might have, guess a general polynomial of degree n. All right, so that's my guideline for how I'm going to make these guesses. And we did 3 examples. 1, that was an E. 2, that was a trig. And 3, well, which was a polynomial. And all 3 of them worked out hopefully reasonably well, or at least we got answers to each of the 3. And it's a little bit painful at times, because you've got to chase around all this algebra stuff, but I suppose in the grand scheme of things, if you can boil an ODE down to just some algebra, that's kind of winning, I guess. So great. So we have a nice strategy. Now, of course, there's some limitations to when this strategy is going to work. The most obvious being that, well, here's our little cheat sheet, or these are the 3 cases for which this is a good idea to work with. So, of course, we have the case of, well, what if it's not one of these 3? Okay. Well, at the moment, we're SOL, I guess, on that, because we don't have a second method or a second strategy just yet. So let's put a pin in that for now, right? So yes, of course, there might be some things that are not these 3. And so we're going to need some other strategy to help us with those. What if we have, I don't know, ln of t, or maybe trig other than just sine and cosine. Maybe you have, I don't know, tangent or secant or something like that. Or so there's going to be some things for which this strategy doesn't quite work. So let me discuss a little bit the limitations, I guess, of the method here, of this strategy, and at least discuss a couple of variations and how to deal with some of the easier situations that we might have that are not quite the ones that are in our chart here. So some we'll call this variations of undetermined coefficients. Okay, so we're not onto our second overall strategy just yet. We're going to stick with this one and see if we can maybe come up with a couple of smart observations. So one is the following. So of course, it's possible the g of t, which remember, of course, that's simply the right-hand side. So it's possible that the g of t, rather than being one of those three cases in the chart, maybe it's a combination of them. So it's possible that the g of t that you're looking at in your problem is a combination of the three cases, of two, or I guess in the worst case scenario, all three, of three cases in the chart. So I'll just give you a couple quick examples of that. So maybe the g of t that you have is something like, e to the 2t times sine of 3t. Or maybe the g of t that you'd have over there is something like, I don't know, t squared minus e to the 5t. Okay, so it's possible, right? It's possible that what you have on the right-hand side is not one of these three, but is actually a combination of two, I guess, or more, if you're a really unfortunate situation, of these. Okay, well, let's take a quick gander at our three examples from last time. These were okay, right? I did my guess. I had, for the most part, a reasonably simple guess that I was making, and I ran it through and I solved for my unknowns. And in all three cases, even though I think the second case was maybe the worst of the three, we had a bit of a mess, right? And of course, the more letters you have to solve for, the messier this is going to be. So if I'm in one of these two cases where I have, well, let's see, sure, I look at this first one or either of these two, and I say, well, I don't know, that's something that I know how to deal with, and that's something I know how to deal with, and that's something I know, that's something I know. Okay, so I know how to do with all four of those individually. But when I put them in conjunction with each other, the most natural thing, of course, to do would be to simply combine the things you were about to guess and use that as your overall guess. All right? So I'm just going to jot this down, and then I'm going to tell you the good news right after this. But humor me here for a second. So if I had, let's say, these two, well, what should I make for our guesses? So our guesses for our particular solution. Make these hours a little longer. Well, in the first case, I have an E thing, so I would probably guess, well, what were we doing? A, e to the 2t. So that would probably address or handle the E portion. And then sine, since we have trig, we would have probably guessed sine, cosine plus sine, right? So if I say, all right, well, I might have guessed cosine. Well, I need a letter in front of that, so maybe I'll do B. and I need a letter in front of my sign piece. So I think I might guess that, right? So that might be my guess, since it's essentially just the product of the two guesses I would have made for the individual pieces. And similarly down here for the second case, again for t squared, I would have probably guessed at squared plus bt plus c. And then for e, I would have guessed a constant in front of the e. Okay, so, right. Now, I said there was good news, right? So, would these work? I think so, right? Well, I should be more confident than that. Yes, these would work. So if you made these, for these two examples we just made up here, if you chose those two to be the respective guesses for yp and did the same treatment that we did in these examples last time, so we make a guess, we do the first and second derivatives, and then we plug it in and solve for the coefficients. If I did that, these would work. Now, why am I being sheepish about this? Well, for starters, what am I not excited about? Many things. One, these have a lot of letters. They both have at least 3, right? And the second one actually has 4 letters, which means when I'm solving this, I'm going to have a bunch of equations. So for the first one, I'd have 3 equations and 3 unknowns. For the second one, I'd actually have 4 equations and 4 unknowns. So the algebra starts to get pretty awful. I mean, this wasn't great, but this was sort of manageable. But the algebra is going to get to be a bit of a problem because you're just going to have a lot of letters to, floating around. Aha, okay, so bad news. Why am I not excited about this? Well, that's one good reason. Another good reason why I'm not excited about it is that in the first one especially, when I try to do the derivative, because we know we need to do the first and second derivatives, this is a product rule. It's actually, in some sense, if you distributed that, you'd actually have 2 product rules. And then when I go to do the second derivative, you'd have twice as many product rules as you had the time before. Aha, okay, so we're rapidly deteriorating into the situation of I don't want to do this, and also into the situation of this can't possibly be reasonable to do because you're just going to have such awful algebra to work with that, right. Okay, so now I promised there was good news here, right? So let's finish this slide with a nice summary here. So these guesses would work. Right, so those guesses we cooked up over there would work. However, right, the algebra and even calculus, doing the derivatives, is pretty awful. Right. Okay, so here's where we say to ourselves, if I'm forced to, or if there was a situation, I'm stranded on a deserted island and I need to solve this, sure. Right, but what we're going to say is we're not going to do problems like these, right? We're not going to bother with awful, god-awful situations like these, right? So this is pretty awful. So we will not, even though we could, we will not do problems like these. Okay, so we're just going to say no thank you. All right? So I think that's I think nobody's going to be upset about not doing those, I think. Right. But you could, in theory, if you really absolutely had to. So that's one variation, is that you end up with basically a combination of the things that you are familiar with and are comfortable with, and essentially you throw the guess together in the most natural way, and it would still in theory work, but we're gonna just sort of dodge those. Okay, so that's variation 1. Variation 2 is going to be one that we do want to address because it isn't actually that hard to fix. So variation 2 is that when we're doing this, we're doing our guesswork. So we guess so according to the chart, we guess a particular solution is whatever, according to the chart. But it's actually already part of the homogeneous solution. Okay, so this is going to happen when we see a problem and we say, okay, I'm going to go do this problem, and it's great, and I solve the homogeneous part first, and I get my two solutions, little y1 and little y2. And I say, okay, I'm going to use the chart to come up with a guess for my non-homogeneous, my particular non-homogeneous solution. But when I look at it, I say, oh, wait a minute. This thing that I'm about to guess is actually already part of the homogeneous solution. So I'm just going to do an easy example of this so you can sort of see what goes wrong. So this is going to be a bad example, I guess, or an example that's going to end not well for us, I would say. So let's look at one, and then we'll figure a nice easy way out of this jam. So we'll go back to our old faithful, I think this is the same ODE we were using in the last video. And then over here maybe we'll do something like 3e to the 4t. Okay, so we've solved this one, the homogeneous version, many times, but I'll just recap it here, right? So I think you get two solutions to this. You get 4 and negative 1, so you get e to the 4t, and our second solution is e to the negative t. Okay, so we have our two homogeneous solutions, great, and now we seek out a way to get one non-homogeneous solution. So we just need one non-homogeneous, one particular non-homogeneous solution. So we look at the right-hand side and we say, aha, all right. So that looks like, so I have e to the 4t over there. And so I think I want to guess some constant times e to the 4t. Because that's, right, a reasonable guess to make. And I say, all right, well, let's see here. I'll do the derivatives. So we're going to need them in a minute. Okay, so I get my two derivatives. That's nice. And now let's plug them in to the ODE, and we'll see what we get. Okay, so we get y double prime, so that's 16a e to the 4t, minus 3 times y prime, okay, and minus 4 times y, and that's all supposed to equal 3e to the 4t. Aha, all right. Okay, so we'll proceed as usual, and not anticipating the disaster that's about to happen. So we say, all right, well, let's see, I got to match them up. I got to see what's on the left and what's on the right. Well, let's see, on the left, I have some stuff with e to the 4t. So let me say, so e to the 4t, so let's see, what do I have? I have 16a, that looks like minus 12a, and that looks like minus 4a. And all of that's supposed to equal 3 e to the 4t. So, of course, in order for this to match up, I have to insist that that be equal to 3. Aha, right. But now we see the problem, which, of course, is that this is 0. And I'm hoping that that's equal to 3, question mark. Oh dear, right. So, of course, I don't think there's any sort of magic that I could actually do. And there's no magical value of a that I could pick that makes 0 equal to 3. Aha, okay. So at this moment, right, we sort of say, well, this is never true. So we sort of have a fail moment here. So this guess and this strategy, not only did I not get an answer, or not only did I not come up with an answer to the problem, I actually got like an impossible situation of like, insanity, right? 0 is equal to 3 is the thing that has to be true for this to work. Aha. Well, I suppose maybe if I had a little bit of foresight, I might have said, well, wait a minute. How is it going to be the case? I mean, let's say, right, my goal was to eventually figure out how much A is, right? So my goal was to eventually say, oh, okay, A is, a half or whatever. But if you think about it, that's never going to work. Because if I was going to say, okay, I solved this and great and blah, 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 so my solution is C1 times Y1 and C2 times Y2, and then my 1, I don't know what A is, but right, if I was actually able to solve this, I would have finished the problem by writing that down. But if you notice, this is a little bit silly, because what does this actually say? This is saying you can take any number of e to the 4t's and then throw a more e to the 4t's. I mean, this is kind of absurd, right? Because, of course, C1 was already any number of e to the 4t's that you want. So even if I didn't get a value for A, but even, I don't know, let's just make something up for a second and said, what if I was even trying to pass this off as a solution? You would immediately say to yourself, wait a minute, well, that doesn't make any sense. C1 is already accounting for any number, any amount of e to the 4t's. Adding an extra 5 of them onto the end is trivial. Oh, but wait a minute, but this is the homogeneous solution, not the non-homogeneous solution that we were looking for. Okay, so there's lots of stuff here that is like, oh no, this didn't work, right? So there's lots of things telling us, I don't want to ruin this completely, so I'll erase this in a second, but yeah, that doesn't work, right? So this strategy doesn't work, and why doesn't it work? Let me erase my big X here. Is because the thing I was guessing, the thing that the chart said I was supposed to guess, was already part of the homogeneous solution. So that's a no-no, because as we can now just see in these last 5 minutes, we just saw that number one, you can't get a solution. And even if, I don't know, somehow you kind of made one, or I don't know, even if you sort of thought you might have one, that's just complete nonsense. There's no way that actually is meaningful, because you've already accounted for it over here. Aha. Okay, so I think the lesson to be learned from this failed example is that if we are in this case, let me just get a clean slide here. So, if the YP we are meant to guess via the chart, is part of the homogeneous solution. Homogeneous, I think I got the right solution. In other words, little y1 and little y2. Then are we dead, or is there a way to save this? And the answer is we can save this. And the strategy is going to say to do the following. It's a very simple idea. Then what are we going to do to our guess? Is we're going to multiply it by keep multiplying it by t until it's no longer part of the homogeneous solution. So let me write that down. Then take this guess that you're we kind of like the guess, right? We like the strategy. It works kind of nicely. So let's not lose this. So let's take the guess that we were meant to make, and let's dress it up a little bit. So this is in essence doing kind of like an integrating factors kind of thing, or a U helper thing, but we're not going to mess around with, oh gee, I wonder what the U could be. I'm just telling you here, right? Is that if you start with this guy, which isn't going to work, if we take that, we should take yp and we should multiply it by the lowest power of t that makes it no longer part of the homogeneous solution. Okay, so jot that down. As usual, it's a little awkward to describe mathy things in words, but this is not a bad description here. And I'll do an example or two. All right, so of course, what's this saying? So this is saying, go ahead and do your guess, right? Make the guess that you are meant to make from the chart. But then since you're not going to do this, I mean, don't do this. Don't actually try it. So you're going to be a little smart here, and you're going to say, okay, here's my guess. And then you're going to check yourself here, and you're going to say, wait a minute. Oh, gosh, that's already part of the homogeneous solution. Oh, all right. So I'm not going to do all this stuff that's on the slide here. Instead, I'm going to say, I'm going to take this guess, and I'm going to modify it. And how am I modifying it? Is that I'm going to multiply by the lowest power of t that makes it no longer part of the homogeneous solution. In other words, my fix is to multiply by t until I'm in the clear. And by in the clear, I mean the new guess is not part of the homogeneous solution. Most of the time, just multiplying by t, just regular old t, is plenty. But of course, remember, we do sometimes have t in our homogeneous solution, in which case we'd have to multiply by t squared. So in reality, most of the time, what is all of this? Let me put a footnote here or something like that. Most of the time, we will be good if we do t times yp. And I would say, if you have repeated roots, you need t squared. Okay? But basically those are the two situations that we're going to find ourselves in. So of course for the homogeneous solution, we know there's three situations. And in each of the three situations, we get solutions. Now, the only case where just multiplying by t isn't going to save us is if you have repeated roots. Then, of course, we know the two solutions are e to the rt and t e to the rt. So if I was going to guess e to the rt, then multiplying by just t doesn't get us out of trouble. We actually have to multiply by t squared. All right, I'll show you an example of each of these. And this is not too tough. All right? So let's try this. I'll do one out completely. I'll save the one that we just messed up, and then I'll at least get another one started so you can see the right guess. Okay, so let's do that. So let's come back to this one that we got stuck on a minute ago. So y double prime and 3y prime and 4y, and that's 3e to the 4t. Okay, maybe the last time, we already know e to the 4t and e to the negative t are my two homogeneous solutions. Okay, and now for a non-homogeneous solution, I would guess, I look over here, and I look in the chart, and I say a e to the 4t, because, well, yeah. Okay, but before I launch into this, I do a little bit of a check first, and I say, okay, am I good? Well, let's see. The thing I'm about to guess is part of the homogeneous solution. Okay, so that's bad, right? So I don't want to do that. And instead I say, well, all right, am I totally dead? No. If I multiply my guess, I'm just going to move this over. If I multiply my guess times t, or if I need to, t squared, that might work. Now, I don't have a guarantee, I guess, although, spoiler alert, this is always going to work. But it's a guess, right? It's still a guess at this point. But let's see. So if I throw a t in here, at the very least, now when I do a comparison, my potential guess over here is very much not covered by the homogeneous solutions over there on the left. Right? So I'm guessing something distinct, or linearly independent if I wanted to use a fancy word. All right, so I don't think I'm going to have that same problem of it sort of collapsing on itself. And I think this guess is going to work. All right, let's try it, because you shouldn't really believe me. Now, unfortunately for all of us right now, this is a little bit of a trickier problem, because now when I try to write down the derivatives, I do have to do a product rule here, right? Because I have one function times another. All right, so I am going to painfully have to do that. So let me just be quick about it, and you can certainly go off to the side if you want to do this in more detail, but hopefully you'll trust that I don't mess this up. So I think if you do the product rule, you get that. All right, so that's the first derivative, and now I need, even worse, I'm going to need the second derivative. Okay, well at least the first piece, that's an easy one. That's 4a e to the 4t. But now once again, on that second piece, I do need the product rule. So again, let me do this quickly. If I do the derivative here, I think you get 4a e to the 4t. And on the other one, I think you get 16a t e to the 4t. Okay, so it's not my favorite thing in the world, but all right, fine. So those are my derivatives. So let's plug them in to the ODE, and we'll see what we get. All right, so y double prime, that's all of that mess there. Now, I guess I do have a little bit of, let's really be a little bit clever, I suppose. I don't really need 4a e to the 4t plus another 4a e to the 4t. That's, of course, 8a e to the 4t. So when I plug that in, how about I save us a little bit of space here and say that's 8a e to the 4t plus 16at e to the 4t. So that's y double prime. All right, and then minus 3. And now I have y prime, that's a e to the 4t plus 4a t e to the 4t. And then I have minus 4y, which is at e to the 4t. And on the right-hand side, I'm apparently supposed to just have 3 e to the 4t. Okay, so potentially it looks like I've gotten myself into a bit of trouble here, but, well, I don't know. Let's see. I only have one letter, A, right? A is my only unknown. So I'm a little nervous because that A is in a bunch of places, so I might be in a little bit of trouble here. But let's see. Let's not panic, right? So in terms of matching things up, well, on the right-hand side, I have some e to the 4t stuff, right? And in fact, I have 3 of them. So let's, on the left-hand side, let's organize who's an e to the 4t. Well, let's see, I got an 8a right here. Now this one has a t in it, right? That has a t in it. So I'm going to leave that, let me leave that alone. I just want the pure ones. So that one's minus 3a e to the 4t. Okay, and that's it. Okay. So who's an e to the 4t, those two terms, and that's got to match this one. So I can already see that I think I know how much a is going to be. Now, what else though do I have? I probably shouldn't just be like, hey, I'll just hope that everything else is okay. Who else is still left over here? Well, the things that are left over here all have t e to the 4t. So let me be a good person here and say, all right. So who's got a t e to the 4t? Well, that one does. That one does. That's minus 12a. And this one, the whole thing, so that's minus 4a. All right, so all of that, just to make a nice summary here, is e to the 4t, 3e to the 4t. And of course, I have no TE to the 4t's. I know that always looks a little funny to write that, but just for the sake of completeness here, that's certainly true that you don't have any of them. So am I in good shape or bad shape when I do my matching? Well, I would need this to match that, and I'm kind of hoping that that matches that. Well, unless I happen to get very lucky, because of course my squiggle here, this is 0. Oh, well, thank goodness. Now that's not an accident, right? So the reason why that's true is because e to the 4t is a solution to the homogeneous problem. So while this would, like, if that's all I had, so, you know, I mean, if that wasn't there and that wasn't there, I'll save them, I promise. Then I'm in trouble once again, right? I get into the situation where I'm just like, well, that doesn't really tell me what A is. But what two things have to be true? Well, on the one hand, I need to insist that 8a minus 3a, that needs to match 3. And on the other hand, my squiggle says that 0, that's what that is, I'm hoping matches 0. Oh, well, it does. Right, so that's like a freebie. Like, yep, nailed it, got it, great. Oh, which leads me to say, as long as I make these two equations happy, I found a solution. Oh, well, this one over here, of course, that just says O is 3/5. Oh, so this is actually much, much better. I do get an answer. It works, right, because this is the whole nature of this plug it in and make it work kind of thing. So as long as A is 3/5, this guess will work. Oh, well, so then I think that means we will have figured out that a particular solution is 3/5 TE to the 4t. All right. And if we want to do our usual nice little summary here at the end, say so, the general non-homogeneous solution is, let me give myself a little space here, big Y, so C1Y1 and C2Y2, and then my 1 non-homogeneous solution. Okay, and of course notice this is very much different than that. I know they both have e to the 4t's in them, but nobody's going to tell me, hopefully, that 3/5 t could somehow just be gobbled up by a constant. There's no way, right? There's a t there. So it's not just a number times e to the 4t. So therefore it is a distinct, independent creature. Okay, so this will work, right? And yes, you're always going to get this nice little 0 equals 0 thing because of the nature of what we've guessed, basically. All right, so this will work. So try this, right? So this isn't too bad. This made for a little bit, again, this adds more, this kind of adds to the calculus, I suppose, right? Because you got to do product rules, and it's not great. But at the very least, it actually kind of makes the algebra a little bit easier in some regards. So I said I would do 2. I'm just going to get the second one set up, and then we'll, I'm not going to do it because it's pretty awful, but, so let me just get one more here going, and we'll finally look at a different ODE. So let's try this one, 8y and 16y, and then maybe I have, what do I have over there? Oh, same thing, so I didn't change that. So 3e to the 14. Okay, so here's our ODE. So we say, all right, well, I'm going to solve this. I should solve the homogeneous problem first. And since I haven't already done this, let's do it quickly here. So of course the homogeneous solution is attained by solving this polynomial. And maybe I got to squint at this for a minute, but I think if you do, you can factor that into r minus 4 squared, or r minus 4 times r minus 4, which of course tells us that my two solutions are 4 and 4. Okay, not a tragedy, but kind of not really what well, it's fine, right? Because we know how to do this, right? So when we get repeated roots, we know that e to the 4t, that's one solution. Now, of course, I'm usually saying e to the whatever the other one t is my other solution. Now, obviously, in this case, I can't say e to the 4t is my second solution, because that would be silly. But remember, when we were discussing our three cases, we discovered via reduction of order that if you put a t in front of your first of e to the 4t in this case, of the one solution, that t e to the rt is also a second independent solution. Right? So this is all from before, right? So those are our two homogeneous solutions. Okay, so that still took a minute or so no big deal. And then we turn to the non-homogeneous problem. And so for that, we look at the right-hand side over here. We say, so I'm going to make a guess based on what I see. And of course, this is an E thing, so I should probably guess, well, an E thing. It's the same thing, right? So e to the 4t, and I'll throw a constant in front of it and say that's my A, and that's my guess. But now again, we have our newfound, I guess I might say, fear here, is that this guess is going to blow up in our faces if it is part of the homogeneous solution. Ooh. Well, it is. Aha. Okay, so just like the last problem that we just did, if I multiply by t, I'll just give myself a little more space here, that seemed to get us out of trouble last time. But now just, be a little bit more careful here. And notice I'm still in trouble because this new guess is actually still covered by the homogeneous solution, right? t e to the 4t, that's also part of the homogeneous solution. Ugh. Okay, which means I have the rare case where multiplying by t doesn't get me out of trouble. So I'm unfortunately going to have to do t squared. Aha. So I'm very quickly going to stop this problem, but let's at least confirm that this guess it's not covered by that, and it's not covered by that, right? The t squared, of course, that's a parabola. That's very different than just putting a t in front of it. Aha. So this new thing is different. It's independent of the homogeneous solutions. And now is where I'm going to say ... If you do y prime and you do y double prime, good luck with that. I mean, there's just a lot of terms, right? You're just going to get a lot of product rules, okay? And you plug all that stuff in to the ODE, oh my goodness, okay? And you simplify, oh, okay? And then you're going to be able to figure out how much A is, right? So if you'll take my word for it, this will work. And you'll get a value for A. Okay, and then of course that means that this guess is now your one non-homogeneous solution. And so as usual, you'll put the pieces together and say C1y1 plus C2y2 plus this one particular homogeneous solution that, non-homogeneous solution that you will have found. Okay? So it will work, right? I'm not going to do it because it's just, well, anyway. I don't know that you have ones necessarily in homework that you'll have for which you need to do the t squared. It's at very least kind of nice to at least acknowledge that you know what the appropriate guess would be, right? I mean, doing all of this calculus and algebra, I mean, it's nice to do it, I guess, a little bit just to make sure you can do it, but it's also borderline abuse at some point, I think, to be like, yes, let's solve, it's kind of harkens back to this whole nonsense, right, of, oh yes, of course, this guess will work. Good luck with your crazy product rules and solving for a bunch of unknowns, and you're okay, right. So, so with that, Let me go back to the end here. So with that, that's the end of undetermined coefficients. So you officially know everything that I think you need to know in order to try these. So there are some problems in the homework for you to try. And just, sort of be patient for the most part. The only thing that tends to go wrong with these is just that you have some algebra snafus here and there. But try these, and in the next video we will get to this elusive second strategy that is going to be useful for when we either don't want to do this strategy, like this would be a prime example of I don't want to do this problem, the one that's on the screen right now, but maybe this other method that we're going to learn about next time will be better, right, for this format, and for other problems as well. So good luck with the homework, and stay tuned for the video on variation of parameters, which is our second method.